Hello, this is Mr. Miller again. Welcome to video 2L. The title of this video is Give Us the Reasons. We're going to go through some very famous proofs, and our job will be to supply the reasons for the statements. But first, I want to talk about the difference between postulates and theorems. A postulate, as we discussed in class, is a statement that we assume to be true. And a theorem is a statement that we're going to prove. That's to be proven. So here we have the same side interiors postulate. It says if two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. For instance, in the figure here, that's saying that 3 and 6, those are same side interior angles, must be supplementary. Or if we wanted, we could pick 4 and 5. Those two are same side interior angles also. So if the lines are parallel, we're assuming that this is true, that 3 and 6 are supplementary or 4 and 5 are supplementary. Okay, now if we assume that is true, then we can prove these other two theorems. We can prove the alternate interior angles theorem, which says that if parallel lines are cut by a transversal, alternate interior angles are congruent. For instance, we could pick 3 and 5. So 3 would be congruent to 5. That's what the theorem is saying. And then also we have the corresponding angles theorem. If we have two parallel lines cut by a transversal, then corresponding angles are congruent. So for instance, angle 2 is congruent to angle 6. So this is what we're up to today. We're going to assume that the same side interior angles postulate is true and prove these other two guys. Alright, so here's the first one. Proof of the alternate interior angle theorem. Wow. Alright, so given that P is parallel to Q, we got two parallel lines. And we're also given the diagram, how the angles are numbered here. And we want to prove that 3 is congruent to 6. Those are alternate interior angles. Well, our job is to supply the reasons. But before we do that, I kind of want to give an overview of how the proof is going to go. So the way this works is that we're going to, well, we know by the same side interior angles postulates that measure of angle 4 plus the measure of angle 6 is going to end up equaling 180. Because that's what the postulate says. Same side interior angles are supplementary. Then, we also know that 3 and 4 form a linear pair. So the measure of angle 3 plus the measure of angle 4 is going to end up equaling 180. Since these both equal 180, they equal each other. So measure of angle 4 plus measure of angle 6 equals the measure of angle 3 plus the measure of angle 4. And we see we have angle 4 on both sides. When we cancel it, what we're left with is what we want, that the measure of 6 and 3 are equal, therefore they're congruent. So there are a lot of little details here in doing it, but I want to kind of get the main idea. It's based on our postulate and a linear pair, and then setting those equal to each other. Alright, so here we go. We have a reason bank here. So on a quiz, I would give you the reason bank. Okay, so you just got to supply it. You got to put the right reasons down for the statements. So first, P is parallel to Q. That's given. Okay, 4 and 6 are supplementary. That's that postulate. We got that postulate right away. And I'm going to abbreviate because I can't write very well. So this is the SSI postulate. So SSI post, SSI postulate. Then 4 plus 6 are 180. Well, that's what it means to be supplementary. So that would be the definition of supplementary angles. So I'm going to put definition of sup angles. Okay. Now, 3 and 4 form a linear pair. That's based on the diagram, so that's given. Okay. 3 and 4 are supplementary. Well, if they're a linear pair, that means that the angles are supplementary. So this is the LP theorem, the linear pair theorem. Man, I'm doing a lot of abbreviating. TH'(M) means theorem, so linear pair theorem. All right. If 3 and 4 are supplementary, they add to 180. That's the definition of supplementary angles. Okay, it took a little while to write. Now, here we get to the statement that I said was going to happen. If 4 and 6 add to 180, and 3 and 4 add to 180, they have to equal each other. That's the transitive property of equality. Transitive property of equality. Okay, now we can cancel the 4s. When we did that, we subtracted a number from both sides. That's the subtraction property of equality. Whoops, that's not my reason bank, but we need that. So subtraction. Sorry about that. Subtraction property. Okay, then we get 3 is congruent to 6. So if the measure of 3 is equal to the measure of 6, that means the angles are congruent. That's what it means to be congruent. So that would be definition of congruent angles. Wow, how's that for abbreviation? All right, a little tricky, but we'll get the hang of this. These proofs are kind of involving parallel lines are kind of similar, so after a while you get the feel for it. Okay, we're going to prove the corresponding angles theorem next, and this is actually almost the same thing. We're just utilizing a different linear pair. So we want to show that 2 is congruent to 6. All right, well, it's going to go almost the same way. 4 and 6 are supplementary, so the measure of 4 plus the measure of angle 6 is 180. 2 and 4 form a linear pair, so the measure of angle 4 plus the measure of angle 2 equals 180. You can see this coming. That means these things equal each other. Measure of angle 6 equals the measure of angle 4 plus the measure of angle 2. Then we can cancel the 4s. We got measure of 6 is equal to measure of angle 2, which means angle 6 is congruent to angle 2. That's the idea of the proof. So again, based on our postulate and linear pair. So almost the same. So P is parallel to Q. That's given. Then 4 and 6 are supplementary. That's the SSI postulate again. Then 4 plus 6 equals 180. That's what it means to be supplementary. So this is kind of going the exact same way. So definitionary of sup angles. All right. 2 and 4 are a linear pair. That comes from the diagram, so that's given. They're supplementary. That's a linear pair theorem. They add to 180. That's what it means to be supplementary. So it's definition of supplementary angles. So 2 and 4 have to equal what we get when we add up 4 and 6. That's the transitive property again. And 2 is congruent, measure of angle 2 is equal to measure of angle 6. That happens when we cancel 4. So that's the subtraction property of equality. And finally, if measure 2 is equal to measure 6, that means they're congruent. That's definition of congruent angles. Now, if you actually look, the reasons are exactly the same as the last time. So these proofs were almost identical. In a minute, we'll do one that's slightly different. Now, just a little comment. These proofs are, and the postulate are, why we can do what we do when we solve problems like these. We're kind of using these theorems without even thinking about it. So here, we're supposed to solve for x. Well, we got to use the fact that the same side interior angles are supplementary. That's the postulate. So whenever we solve problems like these, we're actually using those theorems. That equals 180, so 7x plus 5 equals 180. And if we subtract 5, we get 7x equals 175. And I believe we get x equals 25. Yeah, 25. There we go. Okay, so I'm just doing a quick example here to remind you how to do these. This one, these are alternate interior angles. Well, we use the theorem we proved about that. They have to be equal or congruent. So 2x plus 63 has to equal 5x minus 30. If we subtract 2x from both sides, we get 63 is equal to 3x minus 30. If we add 30 to both sides, we get 93 is 3x, or x equals 31. That's the value of x. That would make those two angles congruent. So these postulates and theorems are important because they justify how we can solve these problems. All right, this is the last thing I want to talk about. We're done. I want to talk about this proof because it's slightly different than the other two. This is a proof of the same side exterior angles theorem. We want to prove that 2 and 8 are supplementary. Well, we're going to start with the same side interior angles 3 and 5. So the measure of angle 3 plus the measure of angle 5 equals 180 by the same side interior postulate. Then we're going to use vertical angles. Since 2 and 3 are vertical angles, their measures are equal, so we could replace 3 with 2. That's substitution. We can put the measure of 2 in for measure of 3. Then 5 and 8 are vertical angles, so their measures are equal, so we can substitute 8 for 5. And we'll have what we're looking for. That the measure of 2 plus the measure of 8 equals 180, which means they're supplementary. So that's the game plan. Use these same side interior angles, replace them with 2 and 8. All right, here we go. P is parallel to Q. That is given. 3 and 5 are supplementary. We're using a different pair this time, but that's still a same side interior angles postulate. 3 plus 5 equals 180. That's the definition of supplementary angles. And 2 and 3 are vertical angles. 5 and 8 are vertical angles. That's given in the diagram. 2's congruent to 3, 5's congruent to 8. Well, if 2 and 3 are vertical angles, they're congruent. That's the vertical angles theorem. Then if they're congruent, their measures are equal. So that's the definition of congruent angles. Now, this is substitution. So we're replacing measure of angle 3 with the measure of angle 2. Because since measure 2 is equal to 3, we can substitute it in. And we're going to substitute measure of angle 8 for 5. And we get this statement here. So that was substitution. And if the measures add to 180, they're supplementary. That's the definition of supplementary angles. Okay, so we're getting this. Now, I realize this is a lot to wrap our heads around, but I think we're doing fine. We're doing better than we think we are. We have to get the main idea of what a proof is for and what a proof is. Writing proofs all on our own will take a little practice, and we'll get there. Okay, for now, just kind of understanding the reasons is the most important step. So I have one for you. You're going to supply the reasons for this proof, and I don't think you need the subtraction property, so don't worry about this. You're going to prove that angle 4 and angle 7 are supplementary. So write 1 through 8 in your journal and write the reasons for the steps. Good luck.